My name is Elena, and I am a software engineer at Decathlon. I'm originally from Malaga, so it means a lot to me to be here speaking today, and I am really happy. Let's take a look on this graph. It shows the average homepage weight that we have by content type. For now, I have hidden the content types. Each of the bars is represented by actually two bars. One is in green, that is for the desktop, and the other one in blue is for mobile. I have hidden the labels because I want you to guess. Does anybody knows which content types takes less amount of weight in a page, or which one takes the most? Text, okay. And he's saying that one of the less one will be text, meaning HTMLs maybe, and one of the biggest one will be images. Any other guess? Where will be JavaScript? So JavaScript will go. Very good, very good. So we have here the content types. We have HTML, CSS, and fonts that takes the less amount of space if we compare with JavaScript or images. Actually, images can take an average of 900 kilobytes in a mobile and even more in desktops. We can say that nearly 55% of the page weight comes from images. And that's a lot, right? And we even don't know how this trend is going to go in the future, because with AI, we can now generate images very easy. So I imagine that the website that we are going to be developing in the future is going to get more and more images. The other day I was doing a prompt. I was asking ChatGPT to generate an image of the Malaga Cathedral. And it came with this really sharp and really realistic image that I'm going to use later in our examples. I have downloaded the image, and we can see that it's a PNG format, and it takes 2.2 megabytes. So let's keep this in mind, because we are going to see later how to use properly this image in our website. But you can say, hey, Elena, this is fine, but in my machine works really well. I don't feel any problem. Everything is very smooth. And I can agree, but probably your machine is one of the latest model in the market. It's connected to a very good connection, like a fast Wi-Fi or even Ethernet connection. And probably you even have some caching or some tools to make it your browser be super responsive. What we need to think is about our end users. And with that, I mean, let's imagine that we have a person that is going to work and then is commuting in the metro, meaning that probably the internet connection is not the best. Is also using a device that is not the lightest one in the market, probably a normal phone. And the user is trying to search for some really nice running shoes. So it accesses our web. So we could feel the pain of that user that is gonna take a while the website to load completely because the images that we have are heavy. So these are the users that we need to think about when we talk about performance. So, because we are going to talk about image performance, I cannot go to this topic without mentioning briefly the core web vitals. These are a set of metrics that Google has defined in order to measure the user experience in our website. There are several parameters that we can measure, but here are the most representative ones. We have LCP, that stands for largest contentful paint, and it measure how much time the largest asset that we have in our page, that usually is an image, takes to load and be visible to the user. Then we have IMP, that is, it stands for interaction to the next pane. And this measures how much we are blocking the user to do another action after the person has, for example, clicked in one of our items. And also we have CLS, that is the cumulative layout shift, and this we have all experienced when we open a website and there is a header, then there is the footer, and suddenly the content jumps and appears the main content of the website. So Google has defined some what considers good, need of improvement, or bad metrics for those. And this is quite important because it's also used by the search engines. So we will improve our appearance in, for example, in the Google search if we have good metrics. Okay, so we already know that the images are important because of the way that it takes in the website. And what can feel that is very smooth for us can not be so good in average for our users. So we can do better for sure. But image performance is not a mystery. We are going to go now through different steps that are actionable, and we can do things to get a better performance in our website without sacrificing the quality. For that, let's start with the image formats that we can use in our website. We have, first of all, JPEG format that is very good for images that are photographs or the ones that has a really large color gradient. It uses lossy compression, and this means that the image is saved without the data of it, meaning that the file size is going to be smaller. So this has some benefits and some disadvantage. The benefit is clear, so the image size is smaller. And the disadvantage is that every time that we are saving an image, we are losing a bit of the quality. This is also not good if we have, for example, a graph which shapes because the quality is getting lost, and also it doesn't support transparency. Oops, sorry. Then we have PNG images that are good for graphics that has transparency. In this case, it's used less compression, and this the quality of the image remains the same. But of course, the trade-off is that the file size is larger. We can also use GIFs that are good for small animations, and usually it's for memes or really small UI effects that we can use, but it's very limited compared to other formats, so it's not used as much as the others. We have as well SVG that is really good for logos or icons because it uses a combination of paths and shapes, so it can scale up and down very good without losing any quality. And now moving to more modern formats, we have WebP that was introduced years ago that has a really good compression. It supports transparency and animation, but the downside is that it's not supported in all the browsers. Another modern format is AVIF, that it is really good for quality. It also doesn't have support for all browsers for now. And also, when we are encoding this to generate this kind of image, the process is a bit slow. So we need to take that into account. So we are going to move now to how we tell the browser that we want to render an image. For that, I'm going to start with the picture element. That is maybe not the most known one, but it's very useful, and it allows us to deliver the best image to the device that is asking for. So this picture is composed by sources and an image tag. So this example that is highlighted here allows us to define several image formats that we have seen before, and together with a fallback. So in case that the browser doesn't support those specific image formats, we are still gonna be able to show our image. The browser will go from top to bottom analyzing the sources. It will check first, do I support the AV format? In case that yes, this image is gonna be downloaded and used in our website. Otherwise, it will go to the next source. If the browser supports WebP, that image is gonna be used, and in case that none of those formats are supported, it will fall back to the JPEG image that we have defined. So this is for image format support, but also it allows us to define device size support. For that, we have the media attribute, and this media attribute will help the browser to decide if an image is accurate based on the size. Going to the example, if I am using a browser that is a large one, meaning that the width of the screen is larger than 1024 pixels, it will download the large image. If that's not the case, but I am using a medium size device, the second media condition is going to be met. So then we are going to use that other image. And if the device is a mobile, meaning that none of those conditions are met, we are going to use the default image here. We can do a combination of these two. We can combine image formats and device sizes. Okay, let's move to the next element that we can use, that is the IMG tag that is more known. And this element is a self-closing element, meaning that we don't need to add at the end the same image with the closing tags. And in this example, we can see that there is a source that is SRC, and this tells the browser where the image is located. And we also have the alt, that means alternative text. And this field is important that we describe as much as possible the image. Why is this important? Because of accessibility. So a person that has some visual impediments, for example, that use a screen reader, the screen reader will be able to read for the user what we have described. And that makes the user be able to understand what is in the page. It's also important in case that the image doesn't download because of the internet connection, because the file is not available or anything, so we can still describe what is the image about. And it's also very important for SEO reasons. So if search engines like Google will be able to read this information and understand what is the content of our page, and therefore our page will be indexed properly. How the browser works in this scenario is like this. We have only added one image, right? So it's the JPEG image. So that image will be used in all the browsers, meaning that either if I access through a mobile, a tablet, or a desktop, that image, same image, is going to be downloaded. And we can already guess a bit what is going to be wrong here, right? There is no responsiveness, so the same file is downloaded everywhere. We can have bad performance, especially in slow connection or mobile phones. And that leads to waste of bandwidth and battery. Here, you remember the image, right, that we have generated before with AI? Here I am simulating a browser, and we can see that with this code that we have just the source and the alt test, the browser is downloading the image that has 2.2 megabytes. Continuing with the example, but in this case using a simulation of a browser in a mobile, we see that the same image is being downloaded. So we are probably using an image that has better quality that is actually not needed for a smaller screen size. So here is the point. And here is where all the image optimization starts. Understanding that we cannot use just one single image for all our devices. And the first smart solution that we can do is to use the SRC sets attribute. So with these SRC sets, we can tell the browser a list of image candidates. The list is separated by comma, and each of the items has first the path that tells the browser where the image is located, together with the width or pixel resolution. So now the browser will be able to choose the best image based on the device screen. We have already some improvements with that, and the first one is that the downloading of the image is going to be per device, so it's more optimized. The page is going to load faster, especially in mobiles, as we will see later, and there is less data usage because we are downloading files that are smaller. Coming back to our example, we can see that we are simulating a desktop that is 2,560 pixels. So the browser will check from the SRC sets which of the elements is defined for a screen width of this value or higher, meaning that in this time the 3,000 image is going to be downloaded. And we can see that this is exactly what the browser has downloaded. The things becomes a bit more interesting now moving to the mobile example, because we are simulating a device that is 375 pixels. So the browser will also go to the SRC sets, and from the list it will check which of the images is defined for a screen width of that value or higher. So it should be, based on what we have seen so far, the 401. But take a look. It didn't go that one, right? We see here in the network tab. Sorry. Here in the network tab is the image of 800. I don't know if it's too small, but believe me, it has downloaded the image of 800. So this doesn't correlate with what I have already explained. And this actually leads me to introduce the next topic. That is about the device pixel ratio. Device pixel ratio is the ratio between the physical pixels and the CSS pixels. If a screen has a device pixel ratio of 2, it means that 2 times 2 physical pixels will be translated to 1 CSS pixel. This concept was introduced in the market when the first high-resolution screen came. And that happens when the iPhone 4 appears in the market. It was a device that has the same screen width as his predecessor, the iPhone 3, but with higher resolution. So with this DPR, we can render images that are sharper. So coming back to the example, now we can see that the device that we are simulating is an iPhone SE that is actually saying here that it has a DPR of 2. So what the browser does is calculating 2 times the screen width. So that means that 375 times 2 is 750. And this is the reason why the browser has decided to get the image of 800, because the resolution of the image that we want to present needs to be higher in this specific device. Okay, this is pretty good. So far we have improved a bit, but if we don't do something else, the browser will understand that the image that we are going to display in our screen is going to take 100% of the width of the device, okay? So for that, in order to be more specific what we need, we can use the sizes attribute. So this allows us to define the layout of our image. So what changes if we use the sizes attribute as it is here? We are telling the browser which device size is get which percentage of the screen width. With this example, we are saying that if the maximum width of our screen is 600 pixels or less, we are going to use 100% of the screen width. In other cases, we are using just 50%. The image is going to use only 50% of the screen. The improvement that we get is that the performance is going to be even better, because we are going to avoid to download images that are bigger than what we really need. So we are being more precise. Okay, this is easier to understand with this example here. So we have the same example as before, right? We have our device that we know already the screen width, 2,560 pixels. The browser will now go and check the sizes. And we'll go from left to right, checking the conditions. In this case, our screen has a bigger width than 600, meaning that we are telling the browser that the image is going to only take 50% of the screen width. And this is actually what correlates to the layout that we have. So doing the calculation, the image will be displayed at 50% of the screen width, meaning 1,280 pixels. So the browser will now evaluate the SRC sets and will pick the image that has been defined for a screen width of that value or higher. So in this case, it's going to take the image that is 2,400. And as we can see here, has downloaded that image. Moving to the example of a mobile, we already know that the screen width is 375 pixels. So the browser will check the sizes. In this case, the first condition is met, meaning that we are telling the browser that our image is going to take 100% of the screen width. So the browser will now go to the SRC set list and will take the image of 400, the image that is defined for a width of 400, right? Not really, right? Because we already know that it's a device with a DRP of 2. So we are already telling the browser that we need double of the pixels for having a bigger resolution. So the browser will then calculate, and 2 times 375 is 750. And therefore, that's the image that is going to be taken, the one that is above, meaning the 800. And we can see here that that was the image being downloaded here. Okay. So we have already seen a bit of what we can do in terms of file size that we are downloading, be more accurate in that way. But we can also ask when the image is going to be downloaded. And for that, we can take a look on the priorities. By default, a browser decides that an image that appears in the early stage of our HTML is going to get a high priority. Images that are tagged with lazy loading or are images that are injected dynamically using JavaScript, those takes low priority, while CSS background image by default takes the lower priority. So this is what the browser does by default, but we can also tell the browser what we need, right? So for that, we can use the fetch priority high in our image tag. And this is very recommended to use in the LCP images. Remember that LCP stands for largest contentful paint, and those are the images that are going to be in the first view that the user sees when the page loads. If we already know that an image is not priority at all, because if everything is high priority, nothing is priority, right? So we cannot say that every image is high priority. So if we have an image, for example, in a visual part of the page that is not loading first for the first view of the user, or is in the footer or something that is not high priority, we can use the the loading lazy tag for that. And what we need to take into account is that the LCP image should be either appearing automatically in the first lines of code of our HTML and should not be injected in JavaScript because those are going to be loaded with low priority by default. And that will influence in our performance metrics badly. So for now, we have seen a lot of manual things that we need to do. Believe me, it's not that much. When you start doing that and get familiar, it's really not much of work. But we can even get some advantage of some frameworks that there are providing some image optimization. So we have frameworks like Next.js, Nuxt, SvelteKit, and probably more that provides image components. So by default, out of the box, those images are automatically being generated in multiple sizes for us. It also converts the image to more modern formats like WebP and AVIF, as we saw before. And those images are attached with lazy loads by default. So taking a look on a real example, we can see this Next.js application. And I am using the image component that it provides. So just defining the source and the alt will, out of the box, will do something for us. As we can see here in the bottom, the image that is being downloaded has some query attributes. And it's actually saying what is the width and the quality of the image that we need. This means that the image is being adapted to our screen size. Also, we can see the type is WebP, and we only have provided the JPEG image. Remember that. So it's automatically converting to more modern formats in case that the browser supports that. And as a result, we can see that the image is only 74.4 kilobytes. So it's quite small compared to the first image that we provided and that we got from our AI. So with these image components, the best practice of image performance is taken care by default for us. Okay, so just to wrap up, I would like to give you some thoughts. First of all is that we need to optimize for our users and also for the planet, because image optimization and optimization in general is not only for user experience, but also means that we are consuming less data, less resources. So also as a developer, we should be careful with the code that we deliver. We should be owning it and take careful decisions. And remember, performance is not a just one-time fix. It's a continuous task. Thank you.